Section 1.4, Other Effective Sampling Methods. Objectives. By the end of this lesson, you'll be able to, number one, describe the difference between the stratified, systematic, and cluster sampling techniques, identify which sampling technique was used, determine an appropriate sampling technique given a situation, and obtain a stratified, systematic, or cluster sample. Now let's review the previous section. Review simple random sampling. Do you remember how simple random sampling works? Visually, it's just numbering each individual and randomly selecting a certain number of them. Here's the image that we used in the previous section. Okay, now we're going to talk about stratified sampling. Stratified sampling is different. With this technique, we separate the population using some characteristic and then take a proportional random sample from each. The definition: a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a proportional simple random sample from each group. The individuals within each group should be similar in some way. Now visually, it might look something like the image below. Now here, with our population, we can easily separate the individuals by color. So in this case here, we have our 12 individuals here. And then we separate this in strata. Strata, we have 1, 10, and 12 in blue. And we have another strata in red. There's 2, 4, 6, 7, 8, 11. And then the green, 3, 5, and 9. Now, once we have the strata determined, we need to decide how many individuals to select from each stratum. It's definitely a weird word, huh? The key here is that the number selected should be proportional. So in our case, 1 of the 4 of the individuals in the population are blue. So 1 out of the 4 in the sample. And so 1/4 of the sample should be blue as well. Now, working things out, we can see that a stratified by color random sample of 4 should have 1 blue, 1 green, and then 2 reds. Now, one example using a stratified technique would be a sampling of people at CMC. To make sure that a sufficient number of students, faculty, and staff are selected, we would stratify all individuals by their status: students, faculty, or staff. These are the strata. Then a proportional number of individuals would be selected from each group. So here's an example, obtaining a stratified example. Okay, so obtaining a stratified sample. Now, the president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. The president divides the DePaul community into 3 groups: resident students, non-resident commuting students, and staff, including faculty, so that he can obtain a stratified sample. Now, suppose that there are 6,204 resident students, 13,304 non-resident students, and 2,401 staff, for a total of 21,909 individuals in the population. What percent of the DePaul community is made up of each group? Okay, so what we're going to do is, for the residents, we know that there is 6,204 resident students out of the total of 21,909. Okay, we want to determine what is the percentage of that. So I'm going to go ahead and open up my calculator here. Okay, and I'm going to take the value of 6,204 and I'm going to divide that by 21909, and that gives me approximately 0.28. So we're going to round that to 2 decimal places to get 0.28, and so therefore that's going to represent 28%. Okay? All right, so let's move this down just a tiny bit here. Now we have the non-resident students. So how many non-resident students we have? We have 13,304. And then we're going to divide that by 21,909, which is the total. So let's go ahead and find out what that's going to be. So we're going to take 13,304, divide that by 21909, and that gives us 0.607. We're going to round that to 2 decimal places, so that's going to be 0.61. So that's 0.61, which represents 61%. Okay, and then the staff, there is 2,401 out of the total of 21,909. So again, let's go ahead and do that division. So 2,401, we're going to divide that by 21909. And that gives us a decimal of 0.109. If we round that to 2 decimal places, it's 0.11. So that gives us 0.11, which then represents 11%. Okay, so now what does this tell us? Well, the president wants to obtain a sample size of 100 with the number of individuals selected from each stratum weighted by the population size. So how many individuals should be selected from each stratum? Well, if we take 28, add 61, and add 11, it's going to give us 100. So how many resident students are we going to pick? Well, we're going to pick 28. Okay, how many non-resident students are we going to pick? Well, from this 61%, that's going to be 61. And then the staff, we can see here that we got a percentage of 11%. So therefore, that's going to be 11. Okay, so now to obtain the stratified sample, construct a simple random sample within each group. So answers would vary for each student, but for resident students, there should be 28 unique numbers from 1 to 6,204. For non-resident students, there should be 61 unique numbers from 1 to 13,304. And then for staff, there should be 11 unique numbers from 1 to 2,401. Okay, now let's go to the next sampling. This is called a systematic sampling. Systematic sampling is obtained by selecting every kth individual from the population. The first individual selected corresponds to a random number between 1 and k. Now note, because systematic sampling does not require a frame, it is a useful technique when you cannot gather a list of individuals in the population. So, to use systematic sampling, we need to first order our individuals, then select every kth. More on how to select k in a bit. Now here's the population. We have 1 through 12. Okay? And then here's the population. We have 2, we have 5, we have 8, and then we have 11. The sample was every third. Okay? So in our example, we want to use 3 for k. And then can you see why? Think what would happen if we used 2 or 4. For our starting point, we pick a random number between 1 and k. So for this visual, we picked the number 2. Now the individuals sampled would then be 2, 5, 8, and 11 because 2, right, plus 3, because k is 3. When we add the 3, we get to 5. And again, every third member. We know that k is equal to 3, so we're going to add 3 to the 5, and that gives us 8. And then likewise, we continue. We know that k is 3, so we add 3, and therefore that gives us 11. So in general, we find k by taking the size of the population divided by the sample size and then rounding down to the nearest integer. Now, systematic sampling works well when the individuals are already lined up in order. Now, in the past, students have often used this method when asked to survey a random sample of CMC students. Since we don't have access to the complete list, just stand in a corner and pick every 7th person walking by. Now, of course, choosing 7 here is just an example. It would depend on the number of students typically passing by that spot and what sample size was needed. Okay, now an example. Okay, obtaining a systematic sample without a frame. Now, the manager of Kroger food stores wants to measure the satisfaction of the store's customers. Design a sampling technique that can be used to obtain a sample of 40 customers. Well, the manager, this is what the manager would have to do in order to find out a systematic sample without a frame. The manager would then decide to survey every 7th customer. So an example, the manager starts with the customer number 3. So the customers who are surveyed under those conditions would then be add 7 to the 3, then it would be the 10th customer. Add 7 to 10, that's going to be the 17th customer. And so on all the way to 276, because the number from 3 to 76, when you add up the sample size, it's going to give you 40. Okay, now what can result from choosing a value of k that is too small? So if we use a value of k that is too small, the sample size may be reached too soon, and the sample will only represent a portion of the population. Now, what can result from choosing a value of k that is too large? Well, the desired sample size may not be achieved. Okay, next we want to explain how to determine the value of k if the population size n is known. Well, you're going to divide the population size n by the desired sample size lowercase n and then round down to the nearest integer. So, these list the 5 steps in obtaining a systematic sample. Well, step 1, if possible, you're going to approximate the population size, capital N. Step 2, you're going to determine the sample size, which is lowercase n. Step 3, you're going to divide capital N by lowercase n and round down to the nearest integer. This value is considered as k. Step 4, randomly select a number between 1 and k. Call this number p. Step 5, the sample will consist of the following individuals: p, p plus k, p plus 2 times k, all the way to p plus n minus 1k. So here is an example. We have 800 math students. We're going to take a systematic sample of size n is equal to 24, starting with student 5. Okay, so the first thing we need to do is recognize what are our values. Well, we know that n, or the population size in our example, is 800. Okay, so there is our first step. Okay, our second step is, what is the sample size? Well, the sample size that's given is 24. So lowercase n is 24. Okay, now in step number 3, we need to find out what is the value of k. Well, the value of k is going to take the population size and divide it by the sample. So if we take 800 and then divide that by 24, then that gives us 33.33. Okay, now remember that we want to be able to find k, and so it says here that we need to round down to the nearest integer. So therefore k is now going to equal 33. Okay, now in step 4, what do we need to do? Well, we need to randomly select a number between 1 and k and call this number p. Well, in step number 4, we're given the value of p. We know the value of p is starting at the value of 5. Okay, so the first number is 5. Okay, and then what is the second number? Well, the second number is taking the value of p and then adding k. Well, p is 5, and then we're adding the value of k, which is 33, which gives us 38. So the second number is 38. Okay, let's go ahead and take a look at the third number. The third number is now taking p plus 2 times k. So that's 5 plus 2 times 33. And so that's 5 plus 66, which is equal to 71. So the next number is 71. Okay, and now what we want to do is we want to go now all the way down to the 24th value, meaning what is the 24th value? Well, recall here that the final number is going to be p plus n minus 1 times the value of k. Well, we know the value of p is what number? Well, we know the value of p again is 5 plus n, which is 24. So again, that's 5 plus the value of n, which is 24 minus 1 times 33. So that means it's going to be 5 plus 24 minus 1 is 23 times 33. Okay, if we take 5 and then multiply 23 times 33, and that gives us 759, and we add 5 plus 759, well, that gives us 764. So the 24th person is going to be 764. So that is an example of determining a systematic sample. Okay, next, we want to find cluster sampling. Cluster sampling is often confused with stratified sampling because they both involve groups. In reality, they're very different. In stratified sampling, we split the population up into groups, strata, based on some characteristic. Now, a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. So here is our cluster population. We have 1 through 12. Okay, so in essence, we use cluster sampling when our population is already broken up into groups, clusters, and each cluster represents the population. That way, we just select a certain number of clusters. Now, with our visual here, let's suppose the 12 individuals are paired up just as they were sitting in the original population. So 1, 2 is paired, 3, 4 is paired, 5, 6, and so on. Now, if we take a look over here, since we want a random sample of size 4, we just select 2 of the clusters. We would number the clusters 1 through 6 and use technology to randomly select 2 random numbers. So it might look something like what we see above here. So we have 5 and 6 and randomly select 11 and 12. Okay, so now moving on, one situation where cluster sampling would apply might be in manufacturing. Suppose your company makes light bulbs and you'd like to test the effectiveness of the packaging. You don't have a complete list, so use simple random sampling doesn't apply. And the bulbs are already in boxes. so you can't order them to use systematic. And all the bulbs are essentially the same, so there aren't any characteristics with which to stratify them. To use cluster sampling, a quality control inspector might select a certain number of entire boxes of bulbs and test each bulb within those boxes. In this case, the boxes are the clusters. Okay, so let's obtain a cluster sample using StatCrunch. So I'm going to go ahead and write this in as using StatCrunch. Okay, so the question here is that a sociologist wants to gather data regarding household income within the city of Boston. We want to obtain a sample using cluster sampling. The city of Boston can be set up so that each city block is a cluster. Once the city blocks have been identified, we obtain a simple random sample of the city blocks and survey all households. Now suppose there are 10,493 city blocks in Boston. First, the sociologist must number the blocks from 1 to 10,493. So suppose the sociologist only has enough time and money to survey 20 clusters, which is the city blocks. So let's go ahead and figure out what those are. In order to do that, we're going to go ahead and access StatCrunch. So if you take a look here, I'm going to kind of move this over just a little bit there. Okay, so you can see here that in your course, when you look at my stat lab down here, you're going to see StatCrunch. And when you select StatCrunch, you're going to have these links that say StatCrunch website. Okay, this is part of your subscription, so you're going to go ahead and then click on that. Okay, and then once you click on that, you want to open up StatCrunch. So right here, you're going to open up StatCrunch. Okay, and then here is the information. So what we want to be able to do, okay, and I'm going to go ahead and kind of minimize this so that we can use this with the same screen here. Okay, so what we want to be able to do is we want to be able to determine what is this cluster sampling with 20 clusters. So the first thing we need to do is we're going to come in here, we're going to select data. And then from data, we're going to scroll all the way down to where it says simulate. And then from simulate, we're going to go all the way up to where it says discrete uniform. Okay, now that we have that, the number of rows and columns. Well, this wants to give us, okay, how many do we want? Okay, now we can say 20, but we want to go a little bit further than 20, so we're going to go ahead and select 25. Okay, and then the columns we have is going to be one column. Okay, now the parameters starts from the minimum. Well, we're going from 1, which is the minimum, to the maximum of 10,493. So the minimum is 1 and the maximum is 10,493. Okay, and then if we go a little further, the store sample is split. We don't need to change that, and we don't need to change anything below that. So now we're going to go ahead and then select compute. Okay, so let's go ahead and take a look at these numbers. So let's take a look at the values here. Okay, so I'm going to go ahead and I'm going to copy everything that we have here. Okay, so here is our values. Okay, so let me see if I can get this just to look a little bit clearer here for you. All right, so if we take a look at our numbers, okay, and I'm going to put this table a little bit smaller here so we can fit this in here. Okay, so our goal is that we know that we need to survey 20 clusters. Okay, which means that in this particular value, we need to stop at 20. So these are the values that we want. So those values here, listed here, are the ones that we want. We don't want anything further than that. And so therefore, that's the numbers that we need. And so therefore, the first 20 are the numbers that we would use. And what we've done is we've obtained a cluster sampling. Now, if clusters have homogeneous of the same kind alike individuals, is it better to have more clusters with fewer individuals in each cluster or fewer clusters with more individuals in each cluster? Well, if clusters have homogeneous individuals, it is better to have more clusters with fewer individuals in each cluster. Now, if clusters have heterogeneous, diverse in character or content individuals, is it better to have more clusters with fewer individuals in each cluster or fewer clusters with more individuals in each cluster? Well, if each cluster is heterogeneous, fewer clusters with more individuals in each cluster are appropriate. Convenience sampling. In a convenience sample, the individuals are easily obtained and not based on randomness. Other methods do exist for finding samples of populations. So in fact, you've seen some already. Probably the most common is the so-called convenience sample. Convenience samples are just what they sound like, convenient. Unfortunately, they're rarely representative of the population. Think of the radio call-in show, those people in the shopping malls trying to survey you about your purchasing habits, or even the voting on American Idol. Note, the most popular convenience samples are those in which the individuals in the sample are self-selected, meaning the individuals themselves decide to participate in the survey. Self-selected surveys are also called voluntary response samples. Now here are some examples of convenience samples. One example of self-selected sampling is phone-in polling. A radio personality will ask his or her listeners to phone or text the station to submit their opinions. Another example is the use of the internet to conduct surveys. For example, a TV news show will present a story regarding a certain topic and ask its viewers to tell us what you think by completing an online questionnaire or tweeting an opinion with a hashtag. Both of these samples are poor designs because the individuals who decide to be in the sample generally have strong opinions about the topic. A more typical individual in the population will not bother phoning, texting, or tweeting to complete a survey. Any inference made regarding the population from this type of sampling should be made with extreme caution. Okay. All right, so let's move on here. Multistage sampling. Often one technique isn't possible, so many professional polling agencies use a technique called multistage sampling. The strategy is relatively self-explanatory. 2 or more sampling techniques are used. So for example, consider the light bulb example we looked at earlier with cluster sampling. Let's suppose that the bulbs come off the assembly line in boxes that each contain 20 packages of 4 bulbs each. One strategy would do the sample in 2 stages. Stage 1, a quality control engineer removes every 200th box coming off the line. The plant produces 5,000 boxes daily. This is systematic sampling. Stage 2, from each box, the engineer then samples 3 packages to inspect. This is an example of cluster sampling. The U.S. Census also uses multi-stage sampling. If you haven't already, or you should have, read section 1.4 in your text for more details. Now, another example of multi-stage sampling, consider Nielsen media research. Nielsen randomly selects households and, through a people meter, monitors the television programs these households are watching. The meter is an electronic box connected to each TV within the household. The people meter measures what program is being watched and who is watching it. Nielsen selects the household with the use of a 2-stage sampling process. Stage 1. Using U.S. Census data, Nielsen divides the country into geographic areas, strata. The strata are typically city blocks in urban areas and geographic regions in rural areas. About 6,000 strata are randomly selected. Stage 2, Nielsen sends representatives to the selected strata and lists households within the strata. The households are then randomly selected through a simple random sample. Nielsen sells the information obtained to television stations and companies. These results are used to help determine prices for commercials. An example of multi-stage sampling. Consider the sample used by the Census Bureau for the current population survey. This survey requires 5 stages of sampling: stratified sample, cluster sample, stratified sample, cluster sample, systematic sample. This survey is very important because it is used to obtain demographic estimates of the United States in non-census years. Details about the Census Bureau's sampling methods can be found in the Current Population Survey, Design and Methodology, Technical Paper number 40. Sample size considerations. Throughout our discussion of sampling, we did not mention how to determine the sample size. Researchers need to know how many individuals they must survey to draw conclusions about the population within some predetermined margin of error. Researchers must find a balance between the reliability of the results and the cost of obtaining these results. Time and money determine the level of confidence researchers will place on the conclusions drawn from the sample data. The more time and money researchers have available, the more accurate the results of the statistical efforts will be. Later in the course, we will discuss techniques for determining the sample size required to estimate characteristics regarding the population within some margin of error. So here is a visual of summary of the main sampling strategies. We have simple random sampling. A sample of n subjects is selected so that every sample of the same size n has the same chance of being selected. Systematic sample, where you're selecting every kth subject. Convenience sample, which is use data that are easy to get. Stratified sample, subdivide population into strata groups with the same characteristics, then randomly sample within those strata. And then cluster sample, partition this population in clusters, groups, then randomly select some clusters, then select all members of the selected clusters.